What's going on, guys? Mr. Jones coming at you once again. All right, right now, guys, we're going to go over Ready, Set, Go 5.1. Typically, these Ready, Set, Goes are homework assignments, but because of distance learning, we've gone a little bit slower, which is why we're going to jump off the Carlos and Clarita problem. We're going to jump off the problem that regards the pet sitting business, and we're going to do some practice problems that are going to help you along the way. So, make sure you take notes of this stuff that I do also in your composition books, because these skills you're going to use over and over, okay? So we're going to go over this very first problem. And then you could do the rest of these four. So it says substitute the given points in both equations to determine which ordered pair satisfies the system of linear equations. A system just means that both linear equations are happening at the same time. And it's saying which of these three ordered pairs over here, A, B, and C, fit both systems. Okay, the only way that it could work with both systems is that's where both lines are going to cross each other. So what it wants you to do is it wants you to take the x value and then take the y value and plug it in and see which one works for both equations. Okay, so you would, let me just give you an example, right? So I'm going to do one that's incorrect. So here's my two equations right here, 3x minus 2 and y equals x. Okay. And what you're going to do is you're going to say, okay, let's say, does the point 1, 4, is this on the graphs? Okay, is it on either one? Is it on both, I mean, at the same time? So you would plug in 1 for x and 4 for y. And you would solve this, and 3 times 1 is 3, and 3 minus 2. Does 3 minus 2 equals 4? No, 3 minus 2 equals 1. So this is not true. Okay, so 1, 4 doesn't work for that equation. Obviously, if you plug it in on this side, if you plug in a 4 here and a 1 here, 1 does not equal 4, so it's also no for this equation. You would need both of them to say yes in order for it to be true. Okay, so that's what you're going to do for the first part. The second part is you're going to graph it, and you're going to see, I'm just going to erase all this, you're going to see if what you figured out as your answer is showing up in the graph. So let's remind ourselves how to figure it out in the graph. Let's remind ourselves how to graph. First of all, both of these equations are written in the form y equals mx plus b. Okay, remember this b is my y-intercept, right? Okay, my y-intercept. This is where I'm literally touching or crossing the y-axis. If you don't know that's what the y-intercept is, write that down. It's where I'm touching the y-axis. Okay, here's my y-axis. Here's my x-axis. This goes 1, 2, 3, 4, -1, -2, etc. 1, 2, 3, 4, and then down to the negatives, right? Okay. The y-intercept means that's where I'm touching and crossing the y-axis. So this is my y-intercept. So at -2, I'm going to be touching, I'm going to be on the y-axis. There's 1 point on my graph. This part's my slope, right? You guys should know that. Slope means rise over run. Okay, if you only have one number, like 3, then you just need to put a 1 on the bottom. So now my rise is 3 and my run is 1. So from your y-intercept, you start here at the y-intercept. From that point, you rise 3. So I'm going to go 1, 2, 3. And I'm also going to run 1. Okay, run 1. So it's all positive. And then I'm going to put another dot. And you could do that multiple times. So rise 3, run 1, rise 3, run 1 if you want. But really, you only have to do it. Let's make this line. Mr. Hernandez showed me how to use this ruler tool. So let's see if I could actually use it and not screw everything up. Okay, so it's about right there. So now I'm going to make a line and whoop, let's make it like that. So now we have this graph, right? Okay. If you don't know how to graph a line using the slope-intercept form, I would definitely look online. How do I graph a line using slope-intercept form? All right, the other graph is y equals x. So you're going to graph that one too. I'm not going to do it for you, but you need a slope and a y-intercept. There's no number at the end, so that number is just 0. And the slope, if it's invisible, is just 1. So I'll help you out and write the equation like this. You should be able to graph this line and then tell me, is that the point, the one that you figured out, whatever your answer was, okay, is that the point where the lines actually cross? Okay, so actually pause the video right now, and then we're going to figure it out. So pause the video, see if you can figure it out, and then we'll come back and we will get that done. All right. All right, so hopefully you figured it out. This is my other line that I graphed, and I got the point. I'm showing you with an arrow that the points cross at 1, 1. Okay, 1, 1. If you don't know how to locate a point, or if any of this is confusing, guys, please come into office hours so we can explain it to you. Math builds on itself, so you're expected to just kind of know what's next and what's going on and how to plot a point and how to do stuff like this. But if you don't, I'll gladly show you in more detail. So 1, 1 was the answer that actually we see on the graph. And you can see from answer C here that 1, 1 was one of the possibilities. So hopefully whenever you guys plug in 1 for X and 1 for Y, you're going to get that they actually equal each other, which is what we want to see. So for problems 1 and 2, you have to plug in the points and figure it out and then graph it. For problems 3 and 4, you're just graphing it. Okay, you're just graphing it. Remember, if you see a negative slope, that means that your graph is going to go in the opposite direction. So both of these graphs are positive slopes. I think I've shown you before. But remember, you have Tom, he always stands on the line. He can only walk to the right. So if he's going uphill, it's a positive slope. If he's going downhill, it's a negative slope. A negative slope would look like this, right? Put him on the line as he walks in this direction, he's going downhill, right? So make sure that if your slope on the problem is negative, like this one, that you're going downhill, that your rise would be down. You can only go down, you can only go negative in one direction. So anyway, there's problems 1 through 4. All right, the set portion has you create a problem. Okay, create a problem. It says determining the possible solutions to inequalities. You're going to solve an inequality. Okay, it says a theater wants to take in at least $2,000. So they can't take in $1,500. They want $2,000 or more for the matinee. Children's tickets cost $5, adult tickets cost $10, and a theater can seat up to 350 people. Find 5 combinations of children and adult tickets that will make the $2,000 goal. Okay, so this is just like the problems we did the last time we were together with the pet sitters. Okay, you need to take this information, cross off the stuff that doesn't matter, and figure out what the constraints are. You can only fit 350 people. Okay, make children X and adults Y or something, and then try and see if you can make an equation that represents this. Okay, and then give 5 combinations that will work. Okay. In fact, you don't even have to come up with an equation if you just think logically like, okay, let's just do some examples. You know, if I chose, I don't know, 100 adults and 250 kids, okay, that's 250 people. Cool. How much money would I make off of those tickets? And then did I make at least $2,000? And then just adjust your numbers accordingly. Number 6 is very similar. Make sure you guys cross off all the mumbo jumbo in the questions, okay? Number 7, use as many of the following shapes in any combination as you need to try and fill in as much of the 12 by 12 grid as you can. You may rotate or reflect a shape if it helps. So you're basically just taking these shapes that look like Tetra shapes and fitting them on this grid. And the goal is to try and see how many different shapes you would fit if you could have no white space at the very end. So this is kind of actually just a fun problem. All right, now the go section. So graph each equation below. Then determine if the point 35 is a solution to the equation. Find 2 points other than 35 that are solutions to the equation and show these points on the graph. All right, so let me just show you what this is talking about. I'm going to pull up Desmos. All right, so hopefully you guys can see my screen okay. Let's see if I can zoom in just a hair. And now we have this equation 1/3 x plus 4. So the question is, does the point, does it cross through the point 3, 5, right? So I'm going to put the point 3, 5 in Desmos so you can see the dot. And then I'm going to graph this equation. So I know the y-intercept is at 4. Okay, so I'm going to have a point at 4. So I'm going to go ahead and plot that on my graph. Okay, so you guys should be able to just do this on paper or whatever, right? So I'm going to put it in red. And I'll make this red also. Actually, I'll leave it green because that's the color we want it to be. All right, so we know we have a y-intercept at 4, and my slope is 1/3. So I'm going to go up 1, and I'm going to go over 3. And that actually brings me from this point to this point. My slope takes me there. Okay, so whenever I was to, now I would draw the line, and there it is. Okay, so if I drew the line 1/3 x plus 4, it does go through the point 3, 5. Okay, so that's what it means to be a solution. It means that that point is actually part of your equation, part of the graph. It sits on the line. Okay, so if I was to say, graph this and tell me, is 3, 5 a solution on the graph? The answer is yes. Then the question was, well, find 2 other points that are solutions. Well, I know what the y-intercept is, so the point there is 0, 4. Now you just basically go from one of these points and you go up 1 over 3, follow the slope, and you'll find a new dot. And look at this point right here. What's that going to be? Ooh, it's hard to get this. So, ooh, 6, 6, right? So if I was to put 6, 6, that's another point on the graph. So the question was, is 3, 5 a solution? Yes, it is. Find 2 points other than 3, 5 that are solutions to the equation, and then show these points on the graph. So on your paper, you're going to do what I did. You're going to plot the points on the graph, show that it is a solution or isn't, and then you're going to show me a couple other points, and you're going to label those as well, but yours will be on paper and not on Desmos. And that's all the way through 11. All right, number 12 says these are arithmetic sequences, so fill in the missing numbers. Okay, so remember, arithmetic means that you're adding by the same number or subtracting every time. So just go ahead and figure out what the numbers are. Remember, once you figure out what each numbers are and what you're adding by, you can find the equation using y equals mx plus b, right? So go back in your notes for arithmetic sequences and say, hey, how do I figure out what the equation is going to be? Okay, remember, we have notes on that. Arithmetic sequences, we have to go back and find the 0th term, but then you should be able to get the equations for all of these. Okay? And then at the very end, each of the sequences begins and ends with the same number. Would the graph of each sequence represent the same line? Okay, so justify your answer there. If you graphed each of these sequences and made them continuous by connecting each point like we normally do, where would they intersect? Okay, so where would these graphs all cross each other if you were to graph them all? Okay? And then that's the end of the ready, set, go. So all of them are due, and that's it. If you guys have any questions, please ask, guys. Please come into office hours in the morning after school. Please talk to us and Go Guardian chat, but figure out a way to ask. It's not embarrassing, okay? It's more embarrassing to get an F. Okay, we would love to help you. Have a great day.